Today in this video we are going to see about Zener diode working and its VA characteristics. So in this following session we will be discussing about how Zener diode is different from PN diode and how does Zener diode breakdown occurs and what are the advantage of that, what is avalanche breakdown and how does Zener diode used as a voltage regulator and its VA characteristics based on the forward and reverse regions. So coming to what is the need of Zener diode. So basically Zener diode is specially designed a PN diode that has optimized to operate in the reverse breakdown region. In PN junction diode, even though it has very good application features, but in case of reverse biasing condition, it will not connect any current during its reverse bias. So in order to overcome this particular disadvantages, the Zener diode is being fabricated with heavily doping on both the sides, producing a very narrow depletion layer which allows a stable voltage drop, which is called Zener voltage. So this particular feature enables Zener diode to work as a voltage regulation for all circuits and stabilizers in power supplies, DC voltage regulators, over voltage protection circuits and reference voltage generators. So coming to the construction of Zener diode. Zener diode is very similar to PN junction diode. As I mentioned earlier, it is heavily doped on both the sides. Because of heavily doping on both the sides, it has a very narrow depletion layer. So it has a sharp and controlled reverse breakdown. Symbol is very much similar to the same diode, but it has a bend line on the cathode. So coming to the working principle, the Zener diode operates in two conditions, forward bias and reverse bias. In forward bias condition, the P terminal is connected to the P side is connected to the positive terminal and the cathode N side is connected to the negative terminal. The depletion layer narrows and disappears at the cathode voltage of 0.74 silicon. During the forward bias, the flow of current is just like normal PN junction diode. Zener diode does not possess any special purpose in this mode. Coming to the next operation, reverse biasing. In reverse biasing, an applied voltage opposes the built-in potential, which will widen the depletion layer. As we all know, in reverse biasing condition, a tiny amount of saturation current flows due to the minority carriers. So this particular diode behaves like an open circuit. So in reverse voltage, when it reaches the Zener voltage, the breakdown occurs. Then the two mechanisms are responsible for this, the Zener breakdown and avalanche breakdown. So this is the Zener diode characteristics. The characteristics it possessed by Zener diode are high current region, reverse leakage region is there. So Zener breakdown region is there and Zener diode, which is the core component of the voltage regulation. When we see about the breakdowns, we have two types of breakdowns. One is Zener diode and in avalanche breakdown. It is available, both are available in the reverse direction itself. In case of Zener effect, the doping of Zener diode will be very heavy, and in avalanche effect it will be moderate or light. The depletion layer, when we consider for Zener effect, it is very narrow, but in case of avalanche effect it is very wide. The sharpness of the breakdown will be very sharp in case of Zener diode, but in case of avalanche effect it is very less sharp. So this is the Zener diode VI characteristics. In forward bias, under some 0.77 voltage, it is considered as the cutoff voltage. In case of reverse bias, the Zener breakdown occurs. It also possesses a sharp curve. So the operation region, the voltage logs at VZ, the constant voltage regardless of current fluctuation will be available in that particular point. So why how the Zener diode can be used as an voltage regulators. So when we are using the Zener diode in reverse bias across the load, even the input voltage varies at any constant level. The constant output voltage can be obtained from the Zener diode. This particular characteristics possesses the Zener diode to act as the voltage regulator. So this is the advantages of using the Zener diodes. We can in industrial purpose. It has been used in motor drives, inverters, PLCs, SMPS, solar, photovoltaic networks, and telemeters, data loops, etc. So on a summary, the Zener diode is being used used as a voltage regulators due to this stable breakdown voltage, and it in forward bias it behaves like a normal diode, and in reverse bias it behaves like a breakdown voltage. It maintains the constant voltage VZ in the reverse bias. Hope in this video you have understood about what is meant by Zener diode, how it is different from pre-n diode, in what are the main characteristics which it possesses during its reverse biasing conditions, etc. Thank you.